Imagine a being so powerful, it can suck in entire galaxies, so mysterious, it's invisible to the naked eye, and so impressive, it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it, and how does it work? The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the universe. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first, let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final, massive boom. A blast so powerful it can outshine an entire galaxy. This blast is called supernovae. During this boom, the outer layers of the star fly away while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that gets too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe, with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic. They may have been dwarfing even the largest known modern stars like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernovae, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our sun, which makes them bigger than any star we know today. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of like a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 10,000 times the size of our sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees Fahrenheit. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees Fahrenheit, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates. leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they are thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifetime, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars comes in. These stars aren't just destructive forces of nature, they're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it, so those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the centers of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack, only instead of a needle, it's an invisible and mysterious object, and instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. Right now, they use a special space probe, LISA, to study them. By combining the information from LISA with other observations, scientists hope to learn more about these terrifying celestial objects. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. And, of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. And when we find out the truth about them, it will become a new page in our scientific history. Shop pirate. R! Hold onto your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Catchunau retroscow, chatue puri say. Our chassis statues, chatis errors, I chain site service. Bait chip vizao, propie, should twice your ain't style. Pirate, is that it? Don, yes, and thank you, Captain Jack. Pirate, my pleasure. R, he leaves. That's right, on. What can I say? He's a space pirate. The Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects, and it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here, you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, there's the center. Here, the most action happens. In the center of the Milky Way, there is a supermassive black hole, which is about 4 million times more massive than our Sun. Sagittarius, a star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius, a star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found. And boy, oh boy, is it an old-timer. Hey, who are you calling an old-timer? A team of brilliant scientists has found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that formed the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past. A very, very distant past. Once upon a time, almost 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down, and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars. And this is far from an easy task. Researchers have discovered the ancient heart, using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars. That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows us to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They're discovering new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers used Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then, they separated out the stars that formed the ancient heart from the stars that originated in a dwarf galaxy, and finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So why is this such a big deal? By studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. You know how it all started 13.8 billion years ago with the Big Bang? Bam! No, wait. I can do better. Thrip! No, that's... never mind. And the universe has been expanding ever since. At its young age, it was all made of gas, mostly helium and hydrogen. For billions of years, the gas has expanded and cooled down. Meanwhile, galaxies, stars, and other mysterious things in space we try to explore today formed because of gravitational forces. And in that chaos, see, just like in middle school, about 4.6 billion years ago, our magnificent planet was born too. It all started as a disk of gas and dust that orbited the young sun. Just the same way it was with the rest of the planets in our solar system, this disk consisted of dust particles of different sizes and gas. They were circling the sun at different speeds and in orbits that weren't stable and predictable. They were bumping into each other all the time. These particles grew from very small grains of dust into boulders, then later into bigger objects called planetesimals that had a range from miles to hundreds of miles in diameter. And these planetesimals that were orbiting the sun within the disk had gravitational force strong enough to pull other objects from the neighborhood out of their orbits and collide with them. As they were constantly hitting each other, they got bigger and bigger until some got to the size of thousands of miles in diameter. That's nearly the size of Mars and the Moon. We know these things because of meteorites. They come from different places all over our solar system and bring all kinds of materials to our planet, giving us something cool to study and learn about our solar system and how it formed. These materials include very small pieces of dust and rock, chondrules, that have gone through the chaos and survived those rough times even before the planets were created. Meteorites also brought pieces of asteroids and planetesimals left behind after the planet-forming process ended. As these objects were forming, some radioactive elements, uranium, hafnium, were left trapped inside the minerals that, again, were part of them. That's how scientists could tell how old they were. But the final stage of Earth's formation, and generally this whole chaos that was happening in our solar system, may have taken a little bit longer, possibly even up to 100 million years more. That's when the last enormous impact was, and the Earth finally reached its full size. What actually happened is that it hit another object which was nearly as large as Mars. This collision was so strong that the impact produced enough energy to vaporize some of the metal and rock both from Earth and the Mars-sized object. And this vapor created a disk that was surrounding our planet. That disk cooled and clumped together at some point, which is when we got the moon. Our moon was the result of the impact debris, which was a combination of hot gas and molten rock. There are some other theories of how the moon formed though. One fission theory claims it broke off from the Earth. Another one, capture theory, says the moon formed somewhere else in our solar system. And at some point, as it was wandering around, it got so close to Earth that it ended up captured by its gravity. And fans of the third theory, co-formation, believe the moon and the Earth formed at the same time, from the same protoplanetary disk. Before the moon formed, the Earth was a much different place. If you could have just one day on Earth without the moon, you'd be first surprised by days and nights. They wouldn't be as stable as they are today because the moon helps to keep the Earth's axis stable. Why are the cranes? Days were shorter back then. The Earth had been rotating much faster before the moon formed. Its gravitational pull slowed the rotation of our planet, which means days got longer. The Earth's rotation is getting slower through time, but at a really small rate. Some predictions say that in a billion years, a typical day will be between 25.5 and 31.7 hours long. If 24 hours is not enough time for you, just wait a billion years. But yeah, if you're the type of person that likes to take things slowly, you definitely have to hurry back then. Although there weren't many things you could do back then to fill your time, besides sailing across the hot lava, collecting rocks, or hoping not to get hit in the head by some fierce meteorite falling onto our planet. But if you were patient enough, maybe you'd see something really cool. Water coming onto our planet for the first time. There was a rain of fiery meteors coming from the sky, and they kept slamming into our young Earth. It looked devastating at first, but some of this falling debris probably held water. Many believe that asteroids and comets that bumped into our home planet carried tiny amounts of water. But considering this meteorite shower lasted more than 20 million years, maybe even up to 200 million years, it's not that unusual that after a while, puddles of water started to collect across the surface. And as the water evaporated within the atmosphere, it would fall back down, forming lakes, rivers, seas, and eventually oceans. Only at that point, there was a chance for some primitive life to evolve sometime in the future. Earth started its transition from a hot ball of magma to the world we know today. Before that, it would be too hard for life to exist there. Even if it had happened somehow, all these meteor and asteroid collisions would have probably destroyed it. Also, you wouldn't be able to survive without an oxygen tank. The Earth did have an atmosphere, but it wasn't like the one we have today. Scientists believe that it was composed of water vapor, methane, ammonia, and some other gases released from volcanic activity. It was too toxic since there were volcanic eruptions all the time, and the temperatures were way higher, so just standing at these early stages of Earth wouldn't be such a pleasant experience. Also, there could even be some form of life at that time. In its early stages, when everything was so chaotic, it wasn't covered in oceans, trees, or stunning landscapes like today, but in molten magma. I mean, the earliest form of life we know about are fossils of microorganisms found in hydrothermal vents, and they're thought to be 3.4 billion years old, and scientists assume The earliest time for life to show on Earth could be 4.2 billion years ago or so, give or take. So, with the right equipment, you could even see some single-celled organisms like bacteria somewhere across our chaotic planet, even before the moon was there. The moon's gravitational pull on the Earth creates tides in the oceans, which means it probably helped mix and circulate ocean water, maybe even shape them. The tides without the moon would be much smaller because its gravitational pull is what causes the tides to rise and fall. The moon also affects life in the ocean. Over time, animals in the ocean have changed and adapted to the changing water levels caused by the moon's gravity. Even just the moonlight has a big effect on sea creatures. For example, corals use the moon cycle to release their eggs at the same time and with stronger tides to help carry the eggs. Baby sea turtles use the moon's light shining on the water to guide them from their nests to the ocean. Who knows which directions life on the Earth would have taken if, at some point, billions of years ago, we didn't get our lunar buddy to follow us along the way. You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so, your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further, 431 light years away. Sometimes, you manage to spot tiny dots circling these stars. Those are planets. And then, suddenly, you see nothing. At first, you're horrified. Has something gone wrong and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can see nothing. The void is a roughly spherical region about 330 million light years across. Our home Milky Way galaxy could fit there billions of times over. And then, it dawns on you. What you're looking at is the mysterious Bot's Void. It lies about 700 million light years away from Earth. In the constellation of Botas, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later, it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light years wide. The Buddha's Void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser. and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So, you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 250,000 C. It means it was formed from a gargantuan star, likely more than 5 times the size of our sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face hidden in a padded hood of a winter jacket. But in reality, this parka is a disc of material with a ring of comet-shaped objects, and the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light years away in all directions. As for the Eskimos' face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring. But astronomers say the nebula isn't a bagel. It's a jelly-filled donut. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue, ball-shaped structure. Each end of this structure sticks out of the ring's opposite sides. Now, you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars, just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of severed and dark silhouettes near the nebula's center, and now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, DGS-at I, it's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DGS-at I was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. The next stop on your space sightseeing tour is the Black Widow pulsar. Just like its spider namesake, this rotating neutron star is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing: a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole, 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. About a year back, something wild happened on Mars. Its magnetic shield and air around it expanded to about 3 times the usual size. Earth has experienced this ballooning before too, in 1999. It caused our magnetosphere to expand up to 100 times its usual size, and scientists are saying that Earth might experience it again soon, but on an even larger scale. The consequences of that could be catastrophic. Let's see why it happens, and what might happen to us if that repeats. NASA's MAVEN orbiter has been orbiting Mars since 2014. It's the only spacecraft we have that keeps track of both the Sun and Mars. In 2022, on December 26, it witnessed a fascinating show on the red planets. Mars' atmosphere and magnetic shield suddenly stretched out by thousands of miles. According to scientists, it's a unique, unbelievably dramatic event, and MAVEN was there to catch it all. Scientists tried to uncover this mystery. Digging into the event, they discovered something incredible. It turns out this airshow was linked to the solar winds. Solar wind is the stream of particles coming from the sun. It's a constant flow of protons and electrons from our star's outer atmosphere. Moving super fast, up to 804 kilometers per second, these charged particles travel through the solar system in a plasma state. Mars, like all the other planets in our solar system, is always dealing with solar wind. Think of it like a breeze from the sun. This wind pushes on Mars's magnetic shield, called magnetosphere, and is part of why Mars loses some of its atmosphere into space. Researchers found out that the weird expansion on Mars happened because there was a rare void in it. Faster solar wind caught up with slower solar wind, making them squeeze together. This created a gap in part of Mars's atmosphere because some solar wind was missing. This unusual situation caused Mars's magnetosphere to expand so rapidly. The Sun goes through a cycle about every 11 years. It jumps from low activity, or solar minimum, to high activity, or solar maximum. Then it jumps back. We noticed this way back in the 18th century, and we're currently on the 25th cycle. It's all because of the Sun's magnetic field. During solar minimum, the magnetic field is strong and organized, but over time, it weakens. Suddenly, solar activity jumps up. This creates solar winds, the sun spewing jets of particles on the planets, including our Earth. In 1999, the solar wind nearly disappeared for 3 days. It will probably repeat again now. This time around, scientists believe it might hit us sooner and harder than expected. The sun becomes quite lively, emitting fiery plasma, developing large dark spots, and releasing powerful radiation. And unfortunately, the upcoming solar maximum kind of caught us off guard. The storm was predicted for 2025, so scientists aren't very prepared. The number of sunspots observed has been way higher than anticipated. The sun hit an 8-year sunspot peak in 2022, and then showed more than double the expected sunspots in 2023. And it's not just them. Solar flares have also been on the rise. In March, the geomagnetic storm lighted up the skies with vibrant auroras across 30 US states. It was the strongest storm in over 6 years. Many rare solar events have become more common recently. For example, a gigantic plasma waterfall, a polar vortex swirling around the sun's north pole for hours, and a 3-day solar tornado towering over 14 Earths. Because of all that, Earth faces some risks. Solar storms could hit our planet. It can mess with communications, damage power systems, and cause blackouts, and even pose threats to living beings. They can ionize Earth's atmosphere. This would mess with radio signals and GPS systems. Major disasters, like earthquakes or tsunamis, combined with such blackouts, could lead to catastrophic outcomes. Additionally, strong solar storms may generate electrical currents that can damage infrastructure, including power grids and rail lines. Airplane passengers might experience higher radiation levels during solar storms. It's hard to tell what that would mean for their health. However, astronauts on spacecraft, such as the International Space Station, could face more significant risks. Future space missions will have to take solar cycles into account. We're not the only creatures in danger. These storms can disrupt the migration patterns of animals like gray whales, sea turtles, and birds. All these poor animals rely on Earth's magnetic field to understand what's going on. And, as a cherry on top, there's a risk of satellite collisions. Commercial space companies are focused on launching satellites quickly rather than safely. Because of that, they often overlook the impact of space weather. During solar storms, the ionized upper atmosphere increases drag on Earth-orbiting satellites. If something goes wrong, satellites can be forced out of orbit and collide with us. The scariest solar storm that has ever happened to us was the Carrington event. In 1859, Earth experienced the most intense geomagnetic storm ever recorded. The sky lit up with vibrant auroras. They were visible from the North and South Poles to places like Cuba and Japan. The display was so bright in the United States that gold miners woke up thinking it was morning. It was caused by a massive solar flare. The auroras were breathtaking, but the impact was more than visual. It disrupted telegraph systems across Europe and North America. Telegraph pylons threw sparks, operators got electric shocks, and conversations were conducted using the auroral current instead of batteries. Similar storms occurred at least 3 times throughout history, with the same awful consequences. Scientists estimate the cost of such an event today could range from $600 billion to $2.6 trillion in the US alone. Researchers continue to study historical events and ice core data to understand and prepare for the potential impacts of future solar storms. The sun's behavior is very unpredictable, but this just shows that we need to study it in greater depth. The chance that this new coming storm will be the same as a superstorm like the Carrington event is low. Besides, if we spend this time preparing, it might go unnoticed. Preparation usually involves adjusting satellite trajectories, grounding planes, and identifying vulnerable infrastructure. Meanwhile, we keep exploring Mars. Its atmosphere is different from ours. Our atmosphere has breathable air, mostly consisting of nitrogen, oxygen, and a lot of other gases. Meanwhile, Mars has incredibly high CO2 levels. If on Earth carbon dioxide doesn't even reach 1%. On Mars, it makes up about 96% of its atmosphere. Also, Earth's atmosphere is over 100 times denser than the one on Mars. Even though Mars is about half the size of Earth, its atmosphere is like a feather compared to our air. But it wasn't always this way. A long time ago, Mars could have been kind of Earth-like. We know that it definitely had water, and perhaps there even were some plants. If we added water on Mars now, plants could have grown up there. A long time ago, Mars was experiencing some serious volcanism, suggesting it had a thick atmosphere and maybe even a giant ocean. We're not sure what happened to them, but there are some theories. For example, Mars has a magnetic field, but it's very weak, so solar winds could have stripped away its atmosphere. In the end, it became the chilly, dusty red planet we know today. NASA's Perseverance rover celebrated its 1,000th day on the red planet with some amazing discoveries. The rover cruised through an ancient Martian river and lake system. It gathered 23 precious samples along the way. All of these samples will help us to unlock Mars's history and geological mysteries. Extreme events and conditions are horrifying, but great in a way that they help us to learn more about our solar system. Luckily, MAVEN was designed to be sturdy and prepared even for intense solar storms, so now we can find out more about Mars when it's stripped of its protectiveness. During the recent years, scientists made 2 breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past, and we've learned something that can change our understanding of the universe forever. What are these discoveries, and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang! It's like getting a sneak peek into the universe's baby album, but that was just the beginning. Astronomers were expecting to see some tiny young galaxies, but what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Labbé, was working at the computer as usual, and suddenly he got 2 numbers. Age, 13.1 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day, they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over, Hubble. There's a new stargazer in town. But why has it shaken things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do. So it looks like after the Big Bang, the stars were forming much faster than we thought. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide and seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Ivo Labbé's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over. James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting. The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world, Xiaolu. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day, we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats, waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered.